Financial transaction.
Okay, hello everyone and welcome to Make Learn 360. All right, please can you hear me now? Sorry for the interruption, please. All right, so thank you everyone. So I'm going to start within the next 5 minutes. Kindly share the link and then I'll start very soon. Sorry for the interruptions, please. Okay. Can you hear me, everyone? Okay. Okay, guys, please, can you hear me? All right. Okay, so without wasting much time, I think we can start now. Thank you very much for joining. I'm really sorry. Please, is the audio okay now? Can you hear me, everyone? Can you hear me, please? All right. Please, can you hear me? Thank you very much. So, my name is Emmanuel, and then I'm going to be teaching you basic mechanics or statics today. I've got some couple of questions to go through with you, and then these questions are basically questions which I took from some of your slides, and then also some of the reference materials which you use. Um, and hopefully, by the time you finish these tutorials, I think you should be able to get something to write. Okay. All right. Okay, so I want us to start from the very basic beginning. Okay, I want us to start from the very basic beginning of the parallelogram law. Okay, so basically, I just want us to start from assuming you just have two forces. Okay, because if you know how to do with two forces, you'll be able to deal with three forces and many more. All right, so without wasting my time, let's look at how to add forces like this. Okay, all right. So essentially, whenever you have a question like this, you've been asked to determine the magnitude of the resultant force. Okay. Yes, it is being recorded, please. It is being recorded. So don't worry, it is being recorded. Thank you very much. All right. So whenever you have something like this and you've been asked to find the resultant force, basically what you have to do is you have two ways, okay? So since we have just two forces, it is good to use the parallelogram law. Now, what is the parallelogram law saying? The parallelogram is saying that whenever I have just two forces, I can treat them as what? A parallelogram. Now, let's see how easy it is to do this. So, you first of all, um, okay, so first of all, let's find the angle here. Okay, now here is 60 and then here is 45. So think about angles on a straight line. Okay, so 60 plus 45, and then if you subtract from 180, that is going to give us what? So that gives us 75. It means that this angle here must be what? 75 degrees. Okay, all right. And now if this is 75 degrees, how can I add these two forces? It's very simple and straightforward. So you come here and then extend this one here. Okay, so if you extend this one, it means that this one is just like you are extending. So it's like you are producing the force which is already, and then you extend the other force which is here. So we call it parallelogram. Parallelogram, it means that parallel sides are what? Equal. Okay, my drawing is not good, but take it like that. So it means this side will also be the 6 kilonewton. So it means that this 6 kilonewton is parallel to this, and then the 2 is also parallel to the 2. Okay, this side is 2 kilonewtons, please. So parallel sides are equal. Are you okay? All right. So now what you have to do is that since you have the parallel sides, then the diagonal is going to be the resultant. So the diagonal is going to be the resultant. That's all. Diagonal is the resultant. That's all. So let's call this diagonal the resultant. Okay. But how will I be able to find the resultant? So this is where many students find it challenging. Now think about this in this way. So if this angle here is 75 degrees, the whole of this angle here is 75. It means that basically, if you look at this carefully, then, okay, I want to do something interesting here. So everybody watch this. Watch this, everybody. Now, if you look at this here, you will realize that this angle here, so if I try to, let's say I can stand anywhere, but let me try to extend this, okay? Now, if I try to extend this, because there is an angle which is between these two forces, it simply means that I just have to find any. So I can either extend it this way or that way. So if I extend it, okay, let's say here. So this one will be what? It's still 6 kilonewton. Are you okay? This is still 6 kilonewton. And this is still 2. But the angle between 6 and 2 is what? Don't forget that the angle between 6 and 2 is always 75. Are you okay? So even if I extend, it will still be 75. Okay. All right. So that means this must be 75. Okay. So essentially, we have been able to get this side of it. Okay. But what we are actually interested in is to basically get please, can you hear me? Okay. Okay, let me continue. Okay, so hello. All right. Okay. I don't know if you guys can hear me well. All right, let me continue. It seems the sound is not behaving well, but I think you can hear me. Okay, so please, if you have not subscribed, kindly subscribe now before I continue. If you have not subscribed, please do well to subscribe now before I continue. All right. Okay, you can hear me. Thank you. Then I'll continue. All right. So at this point, what we have been able to establish is that we have been able to establish the parallel sides. Okay, I just want us to find the resultant. That's all. Okay, so I think this is the best way to go about it. Let me stand here and do it. So if I stand here and do it, the angle between this and this will still be what? 75 degrees. So angle on a straight line will be what? Okay, I can stand anywhere and do it. What I am trying to do is that I am just extending any of the lines so that I will get the angle. Okay, so this one is still 75. And then, so 180 minus 75, that's 105. It means that this side is 105. Okay, so that is it. So to find the resultant, we have to use the cosine rule. So we can say that r squared is equal to 2 squared plus 6 squared, and then minus 2 times 6 times 2 cosine the angle opposite, which is 105. Now let me give you a trick. I can give you a trick. The trick is that whenever the angle is between the forces and you know, it is just going to be 2 squared plus 6 squared plus 2 plus multiplied by 2 times 6 cosine 75. And this will give you the same results. So we have 2 squared plus 6 squared minus 2 times 6 times 2 cosine 105. So the answer is 6.8 kilonewton. Now if you do the same thing here, you get the same results. I hope it's okay. Any question up to this point? Please, any question up to this point? All right. So this is very long because sometimes this confuses people. So if you are not able to get this one, there's another way for you, and that is to use the resolution of forces. Okay? So if you are going to use resolution of forces, you will first sum forces in the x direction. Okay? So let's use resolution of forces. If you resolve the 6 kilonewton, it will get a component along the x and then along the y. Okay? So that along the x is going to be negative. Okay, so first of all, every force going here is positive, and every force going up is also positive. So we have 6. So we have minus 6 cosine 60. Okay, because the 6 is making an angle of 60 with the horizontal and it's going to the negative direction. And then you have 2 kilonewtons here. Okay, now these 2 kilonewton, if you look at the direction, it will get an x component. So 2 cosine 45. Okay, that is the x component. Now for the y, is going to be minus 6 sine 60 because it is coming down. And then also for the 2 kilonewton, that one will also come down. So it will be minus 2 sine 45. Yeah. So if you do this and do this to get the resultant, okay. So the resultant will be square root of x summation fx squared plus summation fy squared. So let's quickly do this, and you see that we will get the same results. So the s component will be minus 6 cosine 60 plus 2 cosine 45 minus 1.585 kilonewton. Okay, then you look at the other one. Okay, so minus 6 sine 60 minus 2 sine 45. That's minus 6.61 kilonewtons. So find the resultant, and you see that you get the same results. So minus 1.585 squared plus minus 6.61 squared. So you see that we got the same results. Okay. Please, any question up to this point? So I'm done with the parallelogram. Any question, please? Please, any question up to this point? Any question? Okay. So I have a moment question here. I've already solved the question, but I will solve it with you again. Okay. So this is a simple moment question. Let's try and see if we can solve it. All right. So let's look at this moment question and see if we can be able to solve it. So this is a simple moment question. Okay. Right. Okay. So whenever we talk about movement, we have what we call the principle of transmissibility. Okay. So the principle of transmissibility. Principle of transmissibility. And I'm going to demonstrate the principle right now. All right. So let's say you've been asked to find the moment of this force about O. Okay. So how will you be able to do this? And that's basically very simple. Okay. Okay, so let's begin. So we are about to find the resultant moment. Okay. Let's start from the 50 Newton force. Or okay, let me just do it together. So summation of moment about O. Okay, summation of moment about O. Let's assume that clockwise is positive. Okay, let's assume that clockwise is positive. All right. Okay. So I want to do this with you guys. I want to do this with you. Let's start from the 50 Newton force. Okay. All right. So when we say movement, think about the 50 Newton force as, let's say you have a rod and then there is a 50 Newton force here. Okay. Now this 50 Newton force which is coming down, so I want to ask you, if you push this rod with this 50 Newton force and then it is coming down in that direction, okay, will it go clockwise or counterclockwise? What do you think? So if you are standing here and you apply this force here on the bar, will it move the bar in this sense or the other way? So clearly it's going to be clockwise. And the magnitude is the moment, the force multiplied by the distance. So it's going to be 50 multiplied by 2. Okay? All right. Now let's look at the 60 Newton force which is here. Okay? Let's look at the 60 Newton force. You see this 60 Newton force here? Okay? What happens is that if I ask you, find the moment of the 60 Newton force about point O, how will you be able to do this? Okay? How will you be able to do this? Find the force of the 50 Newton moment of the 60 Newton force about O. Now let's do something interesting here. So you realize that if you trace the line of action of the 60 Newton force, it will pass through O. Okay? Now, since the line of action is passing through O, then it means that the moment of the 60 Newton force about O is 0. I hope it makes sense. Let me go back again. Now, I am saying that the 60 Newton force is passing through O, and since it is passing through O, it does not generate any moment. So the moment of the 60 Newton force about O must be 0. That's all. How about the 20 Newton force? So interestingly, the 20 Newton force is just at this point here. But we've been asked to find the moment of the 20 Newton force all the way about what? O. Can you see that? Okay. So, to find the moment, it's just going to be pretty much simple. You are going to trace the line of action, and they have done it for us. So, if you trace this line of action here, okay, if you trace this line of action here, it goes through the 20. And now this 20, this force that goes through this one here, there is a distance, okay? There is a distance, okay? Because clearly we can see that. So this is what we call the principle of transmissibility. The principle is saying that if I have a force of 20 newtons, okay, if I have a force of 20 newtons, this force here will still be 20 newtons. It is still going to be 20 newtons, provided I walk on the line of action. I hope it makes sense. Provided I walk along the line of action, provided you walk along the line of action, then it is still 20 newtons. That's all. All right. So that is it for you guys. Now, to find the moment of this force, you need a perpendicular distance from O. You need a perpendicular distance which will touch the line. So the question is, what is this distance here? That's the question. Okay. So who can help us with that distance? Clearly you can see that there is a curved bar here. Okay, there is a curved bar here. So now if I look at the curved bar, from here to here is 3 meters. And then there is an angle of what? 30 degrees. which means that if I want the vertical distance, it is simply 3 sine 30. That's all. And if I want the horizontal distance, it's going to be 3 cosine 30 degrees. All right. So if I look at the 20 Newton force, now another question you want to ask yourself, is it clockwise or anti-clockwise? Okay, so think about, so let's say you have a point here, okay, and think about a force here, which is 20 newtons, and there is a rod. Let's say there is a rod here. Now, if you push it, will it go this way, clockwise or anti-clockwise? Clearly, you can see that the 20 Newton force is trying to send the rod in the anti-clockwise direction. Okay, so that's going to be negative. So minus 20, and the distance is what? 3 sine 30. I hope it's clear. Okay. And then how about the 40 Newton force? So you can also see that the 40 Newton force has got a line of action here. Okay, it has got a line of action which is passing through like this. So all what we have to do is to look at the entire distance. Okay, so already we know that from here to here is 2, from here to here is 2, and we just need this horizontal distance, which now we know as what? 3 cos 30. So 3 cos 30, and that is it. Okay, so it means that we have to add 2 plus 2 plus 3 cos 30. Okay, so 2 plus 2 plus 3 cosine 30. And that's basically 6.598, or let's say 6.6. So, and that force is going to cause a movement in the direction which is going to be what? Clockwise. Think about standing here and pushing the bar down. It's going to turn in the clockwise direction. So plus 40 multiplied by 6.6. So guys, let's add everything up. So 50 times 2 plus 0 minus 20 times 3 sine 30 plus 40 multiplied by 6.6. So that's basically the moment. Minus 5210. Let's check it well. So 50 multiplied by 2 is 100. And then 20 multiplied by 3 sine 30. That's 30. So minus 30 plus 40 multiplied by 6.6. That is 264. So 100 minus 30 plus 264. So the actual answer is 334 Newton meter. And the fact that it's positive means the resultant is going to be clockwise. Any question up to this point, please? Any question up to this point? Because of our time, I will be moving from topic to topic. I'll be moving from topic to topic. So please, if you don't understand anything, let me know. Any question up to this point, please? Please, any question? Okay, let's continue. So let me do this one, and then I will end on moment, because I have a lot of moment questions and I have solved several questions on the channel. Okay, so I just want to solve the last question with you on moment, because if you don't understand moment, you can never understand trusses. So let's spend some time on moment, so that if I start teaching you trusses, yes, please, it will be saved for you automatically. As soon as I end the live stream, you can come back and watch anytime. So let's look at this question. We are to find the resultant moment produced by the forces about point O. Okay. All right. So summation of moment about O clockwise is positive. Okay. Now let's look at force F1. So force F1 has got a component along the X and then along the Y. Okay. So think about it this way. You have a force, one component is going this way, and then one component is going up. Now, it is very simple to resolve. The X component is going to be 4 over 5 multiplied by 500. And the Y component is going to be 3 over 5 multiplied by 500. I have a video on this. You can check the playlist how we do this type of forces. And for this one, it also has, so the F2 is also having two components. One will come down, and that one it will be, so if you look at the angle is 60, so here will be 600 sine 60. And then the S component of the 600 force, the S component is going to be 600 cosine 60. So don't be confused. Along the X, we have two forces. We have the 500 Newton along the S, and we have the 600 along the X. Now, guys, let's calculate the moment. So to find the moment, let's take it one by one. Now, let's look at the S component of the 500 Newton force. So the X will be 400, because 4 over 5 of 500. So let me do it so that everybody will be happy. 4 over 5 of 500 is basically 400. So the question is, what is the moment of 400 about O? Now look at the line of action carefully. You can see that it is passing through like this. So that distance is basically this one. Because by the principle of transmissibility, this line here is still 400. So I just need a perpendicular line, and that's 0.25. So think about it as, and if you look at it carefully, you can see that that force will try to do this, okay, because it is moving in that sense. It will try to move in the clockwise, and that's going to be 400 multiplied by 0.25. Okay, now we are done with the S component of the 500. Let's look at the Y component of the 500. And clearly 3 out of 5, so clearly 3 out of 5 of 500 is 300. So this one gives you 300 newtons. Okay, right. So the line of action again is still going to be this force here. So the perpendicular distance, okay. Interestingly, the perpendicular distance from O is any distance from here that will meet the force. Any distance at all. And that distance is 0.125 plus 0.3. Clearly, you can see that this force, which is going up, will try and send it in that sense. Okay? So that is it. And it's going to be counterclockwise. So minus 300 multiplied by 0.125 plus 0.3. So we are done with the 500 Newton force. Let's look at the 600 Newton force. So the X component of the 600 Newton force is 600 cosine 60. And it is passing through the same line as 400. Okay? So that one, we are not going to spend much time there. It's basically going to be the same thing. So 600 cosine 60, then we multiply it by the distance, which is just what? 0.25. So that one is done. Okay. And then the Y component is passing through this way. So we need this perpendicular distance. Again, it's going to be the same thing. But this time around, you see that the Y component is coming down. So it's going to cause a movement which is going to be clockwise. Okay. So this time around is going to be plus 600 sine 60 multiplied by the moment arm. And that moment arm is what? 0.3. That's all. Sorry. It's 0.3 plus 0.125. Okay. So yeah, so that is it. Any question up to this point? Can someone quickly calculate everything and give me the answer? Can someone calculate everything and give me the answer now? Leave your answer in the comment section. Okay. So what did you get? 69.58. Okay. So let's check and see if it is correct. So 400 multiplied by 0.25, that is 100, minus so minus 300 into 0.125 plus 0.3. Oh, sorry. $127.5. And then 600 cosine 60 multiplied by 0.25. That's 75. And finally, so 600 sine 60 into 0.3 plus 0.125. 220.84. Okay. So a lot of answers are having dropped. But let's see which one is correct. Plus 220.84. And interestingly, the answer I got is not in any of them. Oh, I've made a mistake somewhere. Okay. So this one, I leave it to you guys. Okay. So 100 minus 127.5 plus 75 plus 220.84. 268.34. So how many of you got this answer? So, right. And please, moment is a vector quantity. So you have to bring a direction. So clockwise. Any question up to this point, please? So I'm not going back to moment again. Okay. All right. So let's do 3D. Let's do 3D moment. Let's do 3D moments and forces. Any question, please? Okay. So in terms of 3D movement, this is how we go about it. Okay, okay, let me continue. So let's say you have a question like this, and you've been asked to find the moment. So 3D moment is very simple. It's a cross product, R cross F. That's all. Let me say that again. 3D moment is cross product. So please, those of you who don't understand vector algebra, okay, 3D moment is nothing but a cross product. So by the time you finish this, you should be able to remember the cross product. Okay, so I have two forces, this force here, and then this force here. And then you have been asked to find, so you've been asked to find the moment that these forces create at O. So it's very simple. Let's assume that the moment created by F1 is a vector M1. And then also let's assume that the moment created by the force F2 is also a vector M2. Okay? So what can I do? It's very simple and straightforward. The first thing to do is to say that moment is actually vector M1 plus vector M2, because this one is more or less like summation. Okay, this is more or less like summation, right? So looking at vector M1 is going to be R1 cross F1, and then looking at vector M2, it will be R2 cross F2. So let's look at R1. Now when we say vector R1, it simply means walk from the origin. Okay, so this is the origin. Walk from the origin till you get to the tail of the force. So when we say the tail of the force, whenever you have a force, this is the tail of the force. So this is the tail. It's like a vector. So this is the tail and this is the head. So if I walk in this direction, okay. So let me assign some conventions. So this is positive, this is positive, that is positive. And you can see that walking from the origin to the tail of that force, we will describe a direction along the y-axis. That is 5j. Okay, so 5j in terms of feet. All right. And then R2. So R2 simply means we should start from the origin. So moment is origin dependent. all the time. Please take note that moment is origin dependent. It's very important to know this. So let's start from the origin and walk till we get to B. That will be very simple. And there are several ways to do this. So you can decide to walk along the pipe, or you can decide to climb down. Now, if let me walk along the pipe. So I will walk from here to here first of all. Then I will come here in this direction. Then I will move finally downwards. Now, if I walk like this, this is 5 feet. If I walk in this direction, this is 4. And finally, that is 2 feet. Now, the interesting thing is that walking along the horizontal is 5J. Walking along the pipe in this direction is 4I, because I'm along the x-axis. So plus 4I. And finally, coming down is 2. But then because it is coming against the z, it's going to be negative 2k. So rearranging this is basically 4I plus 5G minus 2k. And that's essentially okay. So R2 is 4I plus 5G minus 2k. Okay. Now we are coming to do the cross product together. So to find the moment vector M1, it is simply I, J, K. And then you put the R there. So it's going to be 0 along the I, 5 along the J, 0 along the K. Then you bring the force F1, minus 60, 40, 20. So minus 60, 40, 20. So I have already solved it, right? But I want to solve it again with you. Okay. And then vector M2 will be the same thing. So we have I, we have J, we have K. All right. Now with R2 is going to be 4 along the I, 5 along the J, minus 2 along the K. And then the force is 80, 40, minus 30. So we have 80, 40, minus 30. Right. So vector M1, or let's say vector M, is going to be the summation. So let's start. So let's start. So this is how we do it. How do we do cross product? How do we do cross product? So you stand here, cancel this column, cancel this row, and write the determinant. So you will get 5, 0, 40, 20. Then you put I here. Then you stand here. So basically it's going to be plus minus plus. So you come and stand at the middle, cancel the whole of this, okay, and then cancel the whole of this, the middle one, minus, write what you have. So if you write what you have, sorry, so write what you have, 0 0 minus 60 20 j. Finally, you come and put the arrow here, cancel all of this, cancel all of this, write what you have. So 0 5 minus 60 40 k. So that is for the first one. Now let's look at the second one. So the same thing, plus minus plus. Okay, stand here, cancel all of this, cancel all of this, write what you have, and that's going to be 5 minus 2 40 minus 30 I. Okay, minus, so you come to the middle, cancel everything here, cancel everything here, write what you have, and that's what, 480 minus 2 minus 30 j. Finally, you stand here, cancel everything here, cancel everything here, write what you have, and that's going to be 480 540. Okay, so we are done. The rest is just, so if I have a matrix A given by A, B, C, D, then the determinant, which is that A, is given by A, B, C, D, which is the same as AD minus BC. And that's all. So please, at this point, I want you to take your time and do this on your own and then give me the answer, because I don't want to go through it with you. If I go through with you, it means I am insulting you. But I don't want to insult you guys, because I believe you can do this. Okay? So take your time and do it, please. I'm giving you 1 minute. Please give me the answer. Okay. Please, what is the answer? You will get a component in I, you get a component in J, and you get a component in K. So I assume that you understand it. Let's move on. Okay, so let's come back and do this before I launch into the deep, and then look at centroid and truss if time permits us, and I'm sure I'm going to do that with you guys. I just want you to understand the basic stuffs. Okay, so that's someone's answer there. You can also do your own. All right. So let's look at when you have several forces. So if you have a question like this, how will you be able to find the x and then the y component? Okay. So without wasting much time, let's start from the 800 Newton force. So this force is having a component. So to get the s, it's very simple. So the s component is going to be, now a simple way to do this is to basically find the magnitude, or let me say, okay, let me do it this way. First of all, find the angle here. When you find the angle here, that's going to be what? So tan inverse of 600 over 800. And that's going to be 600 divided by 800. $36.9, or let's say 36.87. So the s component is going to be 800 cosine 36.87, and the y component is going to be what? 800 sine 36.87. That's all. And that's basically, so 800 cos 36.87, that gives us 639 point, so let's say 640 newtons. And the y, $480. So that's 480 newtons. That's all. All right. Okay. So yeah. So that is it. Now 424 newtons. So simply put, if you look at this force, the angle here, again, so tan inverse of 900 over 560. You can't hear me. Sorry. So tan inverse of 900 over 560. And what is that? So that's basically 58.10. Okay, so the S component is going to be what? Minus. Why is it minus? Because if you look at the direction of the force, it is coming this way. So the X will be moving in this direction, which is along the negative X direction. And the Y2 will come vertically downwards. That will also be negative. So minus 424 cosine 58.10. And the Fy is also going to be minus 424 sine 58.10. So yeah, that's it. So 424 cosine 58.10. That's minus 224.06. And then the Y component is sine. So minus 359.96. Yes, it will be saved. Please, you can rewatch the video again, please. And the last one, which is 408. So 408. So that one too is the same thing. If you look at this side, it is also going to be 900. So the angle is going to be tan inverse of 900 over 480. So tan inverse of 900 over 480. (61.93 degrees). Okay, so the S component is going to be 408. So this one too, the S component will be positive, but then the Y component will also be negative. So 408 cosine. So 408 cosine theta, which is 61.3. So 61.3, and Fy is 408 sine 61.3. Sorry, 61.93. Sorry. So I think the S component is positive, but the Y is going to be negative. Let's quickly do this. So 408 cosine 61.93, and that's basically, yes, please, it will be saved. It will be saved, please. It will be saved. 191.984. And then this one is going to be minus So minus 360 actually. So minus 360. All right. Please, any question up to this point? I want us to start centroids. So I'll be going forward and be coming back in that sense so that you will get any understanding at some point, because there are some people who have a challenge under centroid, others have a challenge under movement, others have a challenge in trusses. So I'll try and make sure that at the end of the day everyone will get something. Okay. Okay, so let's look at almighty centroid, and that's what most of you are afraid of. Let's look at centroid. All right. Please, any question up to this point? Any question up to this point, please? Any question? Okay. So, okay, can you hear me, guys? Okay. So, if you look at, sorry. If you look at what is here, you can see that there is a lot of figures, okay? But I want you to look at these figures, very important. A circle, or let's say, yeah, a quadrant, and then a semicircular area. Please pay attention to these formulas. Okay. Can you hear me, everyone? Can you hear me? Hello? All right. So, I hope everybody can hear me. All right. There is another centroid. Thank you. There is another centroid. Please, can you hear me? Can you hear me, everyone? Hello, can you hear me, everyone? Hello, can you hear? Hello. Okay. Okay, thank you very much. So, these are formulas for centroids, but we have centroid of volume. Okay, you should hear me now. Is it clear now? Okay, so we have what we call. So these are formulas for centroids. So we have. Oh, my voice is very low. Is it okay now? Hello. Okay, I think it should be okay. Okay, thank you. So these are formulas for centroid. Okay, now the funny thing is that whenever you are talking about centroid, we have centroid of, okay, hello, hello. So we have centroid of area, we have centroid of volume, we have centroid of masses, and all sort of things. But at this stage, what you need is centroid of areas. That's all. Now I want you to pay strict attention to this chart, especially quadrant, semicircle, rectangular rectangular area, and then triangle. So triangular area, and then you see another triangular area here. So this one and this one is the same, but it depends on the orientation. Okay, I'm going to solve a question with you right now to show you what it means. So let's solve a question to help you to understand. Okay, so there are several questions here. I want to do this one with you. Okay, let's do this one. I have solved it already, but let's go through this question. I think by the time we finish solving this question, everyone will be able to understand. So I've solved it already, but let me clean everything. Okay, so first of all, what is centroid? What is centroid? So when we say centroid, all what we are trying to say is that there is a certain point in the figure which represent the geometric center of the figure. So a centroid is simply center coordinates. Okay, when we say centroid, centroid simply means center coordinates or geometric center. Okay, so if I ask you, find the geometric center of this figure, how can you find the centroid? Okay, so the first question I will ask you guys, how many areas do you see here? How many areas? Or how many figures do you see here? Okay, so how many areas? You can see a circle, you can see a rectangle, you can see a triangle, right? So three, thank you, three. Good. So now that you have seen that it's three, the next question is, how can we get the centroid of this area? Okay, all right. So first of all, we will deal with the circle. So let's deal with the circle. If you look at the circle, it is interesting. And okay, so there's the origin O. Now let's say if I ask you, okay, three, thank you. Let's say if I ask you, find the x bar of the circle, it simply means walk along the x axis until you get to the center of the circle. If I ask you, find the y bar of the circle, it simply means walk along the y axis till you get to the center of the circle. Now the center of the circle is here. So what is the distance along the x-axis to the center of the circle? Anyone to help us? What is the distance from the origin along the x-axis to the center of the circle? What is the answer? And someone should also tell us what is the distance along the x-axis till you get to the center of the circle. So that's the meaning of x bar and y bar. That's all. Nothing more, nothing less. So you realize that if I want to get to the center of the circle, I need to walk 4 along the x and I will walk 3 along the y. And that's basically the centroid. So here will be 4 inches and here will be 3 inches. Alright, so let's calculate the area. Now, whenever you have a hole is always interpreted as a negative area. Please bear that in mind. In centroid calculation, whenever you have a hole, it is treated as a negative area. All right. So let's calculate the area. That is very simple. Pi d squared, or let's say okay, so pi r squared. I wanted to do pi d okay, let's do the radius. So the area of a circle is pi r squared, and that's basically so minus pi 2 squared. That's minus 4 pi. If you like, you can leave the answer like this. That's fine. Squared inches. Okay, so we are done with the circle. Now let's come to the rectangle. Now, who can tell us the center of the rectangle? Let me come back here so that you understand. If you look at this diagram here, the center of the rectangle is here, okay? So it's like walk from the origin till you get to the center along the S and then along the Y. All right? So let's apply the same principle here. Let's apply the same principle here. Halfway of the rectangle is, so it's 10. So meaning that halfway will be 5. So let's assume that from here to here is 5 inches. And then this whole distance is 8. So I think I've even done it for you. So let's say that the center is somewhere here. And then let's assume that that distance will be halfway, and that's what? 4. So I've done it for you. So what it actually means is that to locate the center of the rectangle, you need to walk from the x-axis 5 and go up 4. That's all. So it means that this one here, so this is 1 inches. That's all. So the x bar is simply 5 inches and the y bar is simply 4 inches. The area is going to be length times breadth, which is 10 multiplied by 8. So that's 80 squared inches. I hope it makes sense. Okay. So yeah, so that is it. Okay. Now there is the most challenging part, which is the triangle. but I hope to make it simple as it can be. So let's go back to the chart and look at the triangle. So let's look at this triangle here. And look at this formula here, which says 1/3. So interestingly, whenever you have a triangle and you take one side as the base, all the time there is what we call the base and then the height. So if I stand at the base, you can see that there is a formula here which is h/3. Okay, there is a formula here which says h/3, right? So that h/3 means that whenever you have a triangle sitting somewhere, then the centroid will always be at a distance which is a height from here, and it is always given by 1/3 of the height. So if this whole distance is, let's say, 8, then it means to get to the center, it is somewhere here, and that distance from here to here is 8/3. That's all. And then again the same thing is happening. So if this whole distance is 6 inches, then this side is assumed to be the base, then the centroid will always act in a distance 1/3 of the height. So this one will be 6/3. So interestingly, whenever you have a triangle like this, all the time, I'm sorry. So all the time, whenever you have a triangle, the centroid in this direction is 1/3, similarly 1/3. That's all. But then we want the distance from here. Okay. So that will be 10 plus 6/3, which is 10 plus 2, which is 12. So the x component is 12, and the y component is what? So it basically means that to get to the center of this triangle, you need to walk all the way here along the x, then you come here along the y, and that's pretty much simple. So 8/3. And then the area is simple. Area of a triangle, half times base times height. So half times 6 times 8. And that's very basic and simple. So that gives us what? 1/2 of 6 is 3. So 24. Squared inch. So we are done. But you see, to find the x bar and the y bar, the easiest way to do it, you can say that summation ai x bar I divided by summation ai. So if you take the area, then you multiply by the x bar, then we add it. So the first, so it means ai, so okay, so it means a1 x bar 1 plus a2 x bar 2 plus a3 x bar 3, all divided by a3. If you want y bar is summation ai y bar I divided by summation ai, which is the same as a1 y bar 1 plus a2 y bar 2 plus a3 y bar 3. divide everything by, sorry, here is a1 plus a2 plus a3. So a1 plus a2 plus a3. And I believe you can do this. It's very simple. Let me do the x bar for you, and then I will allow you to do the y bar for yourself. So a1 from the circle is minus 4 pi. Then you multiply by x bar 1. So 4 times 4. So it's going to be 4 multiplied by minus 4 pi plus a2 s bar 2. 80 and then 5 plus a3 s bar 3. So 24 and then 12. Then divide the whole of this by minus 4 pi plus 80 plus 24. And that gives us the x bar. And so this is basically simple and straightforward. But sometimes if the figures are many, you can draw a table. Okay, so minus 4 pi plus 80 plus 24. So x bar is 6.97 inches. Please work out the y bar. Any question up to this point? Because of time, I am moving straight to trusses, because I think that is where most people are struggling with. Let's quickly move to trusses. Okay. Right. Please, any question up to this point? Okay. So the 12 is coming from the fact that this side here is the base of this triangle. So if I walk in this direction, that'll be 1/3 of the height, okay, which is 6. So it's like 1/3 of 6. Always, whenever you have this, why was the base divided by 3 and not multiplied by 2/3? No, please. It's going to be 1/3 of the height. So forget about this side and look at just this triangle. If you look at just this triangle, then you realize that if I have this base here, essentially this is going to be just 1/3. I hope it makes sense. Okay. So if you still have some doubt after the class, please see me. So the question is, any side at all can be the base. Any side at all can be the base. It doesn't matter. The whole idea is that if I am standing at one side, which I'm calling the base, then the centroid will always try to act at 1/3 of the height in that direction. So if I stand here and call here my base, then I walk in that direction, the height is 6. Okay? If I am saying this is my base, the height will be 6. But if I call here as my base, then the height will be acting as 8. Okay? For the triangle, the x bar is going to be 10 plus 1/3 of 6, which is 2. And 10 plus 2 is 12. I hope it makes sense. So please, if you have not subscribed up to this point, do all to subscribe, please. Okay, thank you. Because of time, let me move to truss. I'll teach you the method of joint. I'm not going to solve all the members, but I'm just going to show you how to go about things. And then if I am able to solve for just some few members, I will allow you to do the others. And then I will look at the method of section. Okay. All right, guys. Okay, so all right. So let's look at this question. All right. So whenever we come to trusses, we have two main methods. We have the method of joint and we have the method of section. And by the time I've finished trusses with you, you would have done equilibrium of rigid bodies. So that's why I didn't treat equilibrium of rigid bodies, because I know that by the time I am done with trusses with you, you would be able to know equilibrium of rigid bodies. Okay, so let's do it together then. All right, guys, let's do it together. So what do we mean when we say the method of joint? Okay, so the method of joint is saying that if the truss is in equilibrium, then all the joints are also in equilibrium. Let me say that again. The method of joint is assuming that if the entire truss is in equilibrium, then every joint is also in equilibrium. So for every joint to be in equilibrium, then that reduces to equilibrium of a particle. So consider all these joints as particles and then forces acting at a point. Okay, so all these joints are assumed to be particles. But before you can look at anything at all, the first thing to do is to look for what we call global equilibrium. So before we even look at equilibrium at joint, let's look at the global equilibrium. So what is happening all around? And that is going to come from equilibrium of rigid bodies. Equilibrium of rigid bodies. And guys, what do we mean by equilibrium of a rigid body? So when a rigid body is in equilibrium, then two things are certain. Number one, summation of all the forces external to the body is 0. And then summation of movement at a point is also 0. Let's apply these two conditions. Okay, so if you look at A here, we have a hinge. And then if you look at B here, if you see small balls here, we always call it a ruler support. Please, the free body diagrams is what I am doing right now. By the time I finish this, you should be able to know free body diagram. So whenever I have a ruler support, that is it. I'm not going to clean this diagram. I'm just going to use this diagram for the analysis. Right. So if you look at this point here, this is like a hinge. So for hinge support, you have only one, for hinge support you have two reactions. So AX along the X, AY along the Y. But for a ruler support, only one reaction. There is a full video which I have done. On free body diagram. Please, I will encourage you to watch that video. I did a full video on free body diagrams and I have sent it to the class reps. A full video which I have done on centroid. I think it will help you guys if you watch it. A full video on everything you have to know about free body diagrams. Okay, so let's start. So number one, we are saying that summation of forces is 0. That means summation of force along the X positive in this direction is 0. Summation of forces along the Y positive in this direction is also 0. Make sense? Right. So let's look at the summation of forces in the X direction. So the question is, do you see any force along the X direction? Is there any force you see along the X? The answer is yes, and that's AX. But then it is only AX, so it means AX is 0. Now what this means is that if AX is 0, then actually there is no force in the X direction. And it makes sense because you can see that the loads have been applied all along the Y. So interestingly, there is no force in the X. Okay, so the question is, how can I find AY and then HY, the support reactions? And that is what we are doing now. So let's sum forces in the Y. Every force going up should be positive is 0. That's what we said, equilibrium. Right. So AY is coming down, and that's minus AY. Because every force going up will be positive. AY is coming down, so minus. And then there is a 1 kilonewton force here, so minus. Okay, so I want us to do this together. All these forces, let's add them and negate them so that we can go faster. So 1, 2, 2, 1.75, 1.5, 0.75, they are all coming down, so they will be negated. Let's add those forces and negate them quickly. So 1 plus 2 plus 2 plus 1.75 plus 1.5 plus 0.75, and that's 9. Meaning everything here is just minus 9. Then hy is going up. So plus hy should be 0. So we can say that minus ay plus hy should be 9. Let's call this equation 2. But we have two unknowns in one equation. And whenever we have two unknowns in one equation, it means this equation cannot be solved. Two unknowns in one equation. It means we need another equation, because if you have two unknowns and two equations, should be able to solve. Now the question is, where is the other equation going to come from? So the other equation is going to come from moment. So we will stand at any point, let's say point A, and some moment. Let's say clockwise is positive. So you see, should be equal to 0. You see that at this point, if you don't know moment, you can't go again. So that is why everything you are learning comes into application here. Because if you don't understand moment, now you can't go again. As a matter of fact, if you don't even know how to draw free body diagram, you wouldn't know how to look at the reactions. Okay, without wasting much time, let's take moment about point A. Now, because we are taking moment about point A, the moment of 1 kilonewton and then ay about point A is 0. So that is it. Okay. Now, we will be dealing with the distances at the top here. Okay. And quickly, let's do this together. So 2 kilonewtons is having a distance 4 from A, and it's going to what? Clockwise. I hope it makes sense. So we have 2 multiplied by 4. So we have 2 multiplied by 4, and that's positive. Again, we have 2 multiplied by 8, which is 4 plus 4. Again, we have 1.75 multiplied by 4 plus 4 plus 4, which is 12. Okay. Again, we have 1.5 multiplied by 12 plus 3, which is 15. Again, we have 0.75 multiplied by the whole length, which is 18. So 0.75, 18. Okay. Now, the last one is hy. You see that hy is going this way. So that one will be counterclockwise, but then so it's going to be minus 18 hy. Are you okay? So that one is going to be minus 18 hy. Any question up to this point? Should be 0. So guys, what is hy? So 18 hy is going to be what? So 2 multiplied by 4 plus 2 multiplied by 8 plus 1.75 multiplied by 12 plus 1.5 multiplied by 15 plus 0.75 multiplied by 18. And that's it. 81. And what is 81 divided by 18? 4.5. So HY is 4.5 kilonewton. That's all. So we can go ahead and change HY here and make it 4.5 kilonewton. All right. So if you look at everything here, we are done. But we are coming to now find the forces. So you see, before you even start anything, okay, what is AY? Let's substitute HY into equation 2. So we can say that minus AY plus 4.5 is equal to 9. So we can say that AY will be 4.5 minus 9. And that is minus 4.5. Whenever you solve for reaction and you get negative, it means that the direction you chose is the other way around. So you basically go back and change it. So AY is going to be 4.5 kilonewton. Okay. So please, let me say this again. Whenever you solve for reaction and you get negative, go back and change the direction. So AY is actually going to be 4.5 kilonewton. That's all. Right. So we are done with the first part, which is the equilibrium of the rigid bodies, because now we've been able to find the support reactions. Okay. So how can I find the forces in the members? So to find the forces in the members, you have to treat each joint as equilibrium of a particle. And how do we do that? Okay. So if you take AB or member AB, the force acting in AB is AB in this direction. At the same time, it will be AB in this direction. That's all. If you look at AC, it will be AC in this direction and then AC in this direction. So this is FAB and this is FAC. So according to Newton's third law, action and reaction are equal but opposite. So think about it this way, that if I have a member which is having, so what I'm trying to say is that if there is a point here, let's say A, and there's another point here B, along member AB, there is a force and there is another force, and we call this FAB. Along A and C, there is a force and there is a force. These forces are equal and opposite. We call this FAC. I hope it makes sense. Okay. All right. So I will not do all of them because of time. I will not do all of them, but the principle is the same for the method of joint. So you take each joint, you do the same thing. You take each joint, you do the same thing. So the same thing, okay? So I don't need to do. That is why the method of joint is not good. Because if you have 100 members, then it means for each joint, you are going to get 100 equations. And think about how it's going to be many. So that's why the method of section is good. So that if I want to find the forces in a certain member, that one will be straight. But because of time, I will not do method of join today. Maybe if we can get time tomorrow, we will do another one. Okay. So I just want to solve for some members FAB and FAC, and then I will end the video. I'll end the tutorial for today. If you have a certain question you want me to help you with, you can talk to me directly after the class. Thank you. Okay, so let's start from joint A. Now, if you look at joint A, you will see that at joint A, what is happening? So at joint A, this is A. You can see that there is a force. So you can see that there is a force FAC, and there is a force coming here, which is 1 kilonewton. And then there is a force coming up, which is 4.5. And then there is a force, which is FAB. Okay. So that is it. We have 1 kilonewton. We have 1 kilonewton, 4.5. So you see what has happened. This has been reduced to finding the force equilibrium of a particle. Now think about it like there's an angle here. So this is actually equilibrium of a particle. So for a particle to be in equilibrium, summation of force along the x should be 0. Summation of force along the y should be 0. Summation of force along the z. But this one, there's no z. So for a particle to be in equilibrium, sum of all the forces should be 0. I hope it makes sense. All right. So let's quickly do this. So summation of forces along the x. So we have FAC. Okay, so should be 0. So we have FAC, which is along the x direction. Okay. Now FAB we don't know, but it is inclined at an angle. Guys, let's find this angle. So if you look at it carefully, what do you think will be the angle? As a matter of fact, so I'm talking about this angle here. What is this angle? That is going to be straightforward. We've got so we've got the whole of this as 12, and we've got the whole of this as 6. So if you clean everything and you treat the whole of this as one complete triangle, then you realize that basically this angle here is nothing but tan theta, which is 6 out of 12, which is 1/2. So what is tan inverse of 0.5? $26.56. Okay, so it's going to be 26.56 should be equal to 0. Is there any other force along the x? No. So we are done. So let's call this equation 1. Now let's sum forces in the y. Every force going up should be positive to 0. 1 kilonewton is coming down, so minus 1. 4.5 is going up, so plus 4.5. And then FAC is horizontal, so 0. No need to do anything. But FAB along the y, so FAB sine 26.56. Right. So basically we can find FAB in it. So it's going to be FAB sine 26.56 should be equal to what? So 1 minus 4.5. So that FAB will be 1 minus 4.5 divided by sine 26.56. So 1 minus 4.5 divided by sine 26.56. That is minus 7.83. Minus 7.83 kilonewton. So the minus sign simply means FAB is in compression. So you just put C here, compression. Then you go back and substitute FAB into this equation to get FAC. Okay? So FAC would then be minus FAB cosine 26.56. And that is going to be minus minus, so it's going to be plus 783 cosine 26.56. And that's going to be what? So 783 cosine 26.56. So basically that's going to be 7.0 kilonewton. And because it is positive, it means it's in tension. So guys, this is where time will permit us. I plan it to be 2 hours. I can't cover everything, but maybe if we get time tomorrow, we will go through some other questions. And I think even with what we have done today, you should be able to at least pass. Okay. So thank you very much for joining, everyone. If you have not subscribed, please do well to subscribe and share the link to all your friends. Thank you very much for joining. See you guys. Bye-bye. Please, if you have a question, my contact is there. Contact me directly. Thank you. With what we have done today, you should be able to at least pass. Okay. So thank you very much for joining, everyone. If you have not subscribed,